All right, I'll be honest with you. I don't feel like Chapter 7 was so bad so far. Chapter 7 so far has been basically looking at graphs and looking at the points that where they cross zero and just identifying them. Um, that's really all it is, and just this concept of f of x being equal to g of x, right? And the way we solved it is we took f of x minus g of x is equal to zero, and then basically, then basically we found what the graph of that new function is, and we looked, oh, where does it cross the zero line? Oh, that's where it is. That's the x-intercepts. Boom, that's our answers right there. Are we cool with that? With 7.3, the only added complication I'm doing is I'm saying f of x is less than g of x or greater than, but basically inequality. That's what we're dealing with here. We're dealing with inequalities in there. And just as a quick kind of remember this, I don't know if you remember this, but if I had something like negative x, or let's go with negative 3x is less than 9 or something like that. If I want to get x all by itself, I divide both sides by negative 3, negative 3. When I divide both sides by a negative number and I'm dealing with an inequality, do you guys remember what you have to do? You have to flip it. Yeah, exactly. So it would be x is greater than negative 3. So, and that's old school. I think that's from like algebra 1. No, you don't take the reciprocal. The reciprocal means you flip it upside down. That's like taking a fraction and turning it on its head. But flipping the sign, that's what we mean, or flipping the inequality sign. So if it's less than, it becomes a greater than sign. If it's greater than, it becomes a less than sign. And then same go with all the equals to's. Got it? So that's a pretty straightforward business, and just to kind of remind you that that's in the horizon there. If I had something like x squared minus 4, and I want to figure out when it's, or let's do this one. I'll ask you the question, x squared is greater than 4. Okay? Or maybe x squared minus 4 is greater than 0. Let's do that. Okay? What I'm going to do is I'm going to graph this thing. And I'll graph this one, x squared minus 4. So going back to our old school parabola, we know that this is just a regular parabola dropped down 4 units. So 1, 2, 3, 4. Are we cool with that? Finding the zeros is actually pretty straightforward as well. You can say, I could just set this thing equal to 0 instead of less or greater than 0, and I can just say, all right, x squared is equal to positive 4, and so x is equal to plus or minus 2. And so I know that the x-intercepts is at plus or minus 2, and I don't think that it would take you some magic convincing or anything for you to agree with me on that. So really what I'm asking for is x squared minus 4 is greater than 0. All you really need is, what I'm asking is, what x values give me an answer where my y value is bigger than 0? What x values give me an answer where my y value is positive? And here's the y values, all of these ones. And in this area, in this region right here, all over here and all over here, my answer is positive. It's bigger than 0. Not including negative 2 and positive 2, of course, because if I plug in negative 2 into here, my answer would be 0. Not bigger than 0, just exactly equal to 0. Does that make sense? Yes, no? So the way you would put in this answer is pretty straightforward. You could either put, I think this is called symbolic notation, and I think you would put something like x is smaller than -2 or x is greater than 2. The way I like doing it is actually, and the way I think that I'm asking you to do it in your homework is I'm actually saying put in interval notation -infinity to 2 union 2 to infinity. And you're asking, well, how am I going to put that into the homework? And I think that what I do is I have you type it up and I say use /infty, actually /-infty, comma 2, close parentheses, capital U, 2, comma /infty. And you have to type that in exactly, because obviously there's no real like good way for you to type up mathematics in on the computer as far as like where's the infinity symbol on your or key on your keyboard. You know what I mean? And I think that you learn interval notation in Algebra 1. Are we pretty comfortable with this interval notation thing? Yes, no, maybe? No, yep, okay. So, wait, so Mr. Benz, I was just wondering, are you comfortable with this? Do you understand that answer? Okay. Yeah. I know that I've covered this before. But if you're comfortable with this, basically it's saying that the answer lies in between -infinity. Actually, this is interval notation. This is just typing it. And I'll tell you what, as a gift for those of you who came in, why don't we open up some homework and actually take a look at some homework and do the homework for you. Cool? But before we get there, let me kind of expand on this thing a little bit. I think that what I did for you when I first took a look at this problem yesterday, I said, okay, if I want to solve x squared minus 4 is bigger than 0. Now, we know how to get our answer from the graph. And if you do that, that's fine. You know what I mean? But I don't necessarily like... Oh, what's the difference between set notation and interval notation? I think that this is called interval, and this is called set. It's just a different way of writing it, to be honest with you. It means the same thing. All right. When you can graph it, we get our answer, that's fine. But when I originally looked at this, I said, all right, x squared minus 4 is equal to 0, so x squared is greater than 4, so x is greater than plus or minus 2. And I think there's a problem that I have with this. Because if you look at this answer, this says that x is greater than positive 2 or x is greater than negative 2. You see what I mean? And the problem here is that it actually, if you look at it on the number line, our original answer went from here out this way and also from here backwards that way. But the answer we're getting now is looking like this. You see what I mean? And I think that what you have to do, to be honest with you, is you have to kind of be careful with this part right here. X squared x squared is greater than 4. And maybe maybe what we should do is probably think of it like x squared is greater than 4. X squared is always a positive number, right? X squared is always a positive number. So I almost am tempted to say that we should probably think of this as the absolute value of x squared is greater than 4. And then when you look at that, you can say, oh, okay, well, that means either x squared is greater than 4 or x squared is less than 4. And then you could say x is greater than 2 or x is less than negative 2. This is the positive side. This is the negative side. And when I took the square root of both sides, I said, okay, usually I would put a plus or minus here, but since it's the positive side, I'm going to put the plus version. And since this is the negative side, I'm going to put the minus version. I don't know how comfortable you feel with that. To be honest with you, if you look at the graph, it's so much easier for you to understand. But this is kind of my justification for this. Now, do you folks remember, like how comfortable do you feel with this step right here? Like you understand why I took the absolute value and then I said, okay, well, it's either bigger than the positive version or smaller than the negative version. Okay, all right, cool. Because when I teach that in Algebra 1, I have this story that I usually go through. But like I said, I'll be honest with you, I think that the best thing for you to do is not try to solve it algebraically, but actually try to kind of think about it really, well, what is this graph doing, and how do I go about solving this? So let's try another one. Let's try x squared minus 4 is smaller than or equal to 0. Okay. If I graph the left side in my head, I can make an ugly graph of this right here. I know this is negative 2, I know this is positive 2, I know this down here is negative 4. That's just graphing the left side on my head. Boom, done. Now, when is the y value smaller than or equal to a negative number? Or smaller than or equal to 0? That's really my question. When does my graph dip below this line right here, in this region? You guys are alive? All right. This left side, let's say it's f of x. This right side is g of x. If I were to graph f of x, it's that parabola that you see. If I were to graph g of x, it would be a straight horizontal line at 0. Does that make sense? When is the orange graph lower than or below the black line? At negative 2. Yes, I agree. Negative 2 is definitely an answer. Give me another answer. So at negative 2, I agree. At 0, exactly, I agree. Down here. In fact, I would almost venture to say that anywhere in between here, if I'm talking about an x value for my orange graph, I'm talking about anywhere between negative 2 and positive 2 will fill out this region right here. That is the section where the orange graph is below the black graph. Do you guys see what I'm getting at? Do you guys agree? So one way to write that is to say, well, negative 2 is less than, negative 2 is less than or equal to x, which is less than or equal to 2, or x is between negative 2 and 2. I think the easier way to write an interval notation is to say, well, it's between negative 2, comma 2. And instead of putting parentheses, I put brackets. And the reason for the brackets is because it's simply because if there were just a pure less than sign, then I would put parentheses, because that doesn't include negative 2. But since there is a less than and equal to sign, I'm going to put a bracket, which means I'm including the number negative 2 in that answer. Are we cool with that? So just flipping the sign actually made our answer look drastically different. Our answer up here was almost 2 regions, whereas our answer over here was 1 region. I don't know. I'm hoping this makes sense to you. Let's try this one right here. All right, this one looks good. Okay, look. This right here is f of x. F of x is a parabola, quadratic equation. G of x is a straight line that has a intercept of what looks like a y-intercept of negative 9. It's got a slope that you could figure out, all of that kind of stuff. All of that jazz, you can figure it out. Got it? How many solutions are there to the equation f of x is equal to g of x? When does f of x equal to g of x? I'll show it to you. It's right here and right here. At those 2 points, the x values will be the same and the y values will be subsequently the same. So there are only 2 solutions. But then my next question is, how many solutions are there to the inequality f of x is bigger than is smaller than g of x? Well, I could have at x equals 0. At x equals 0, notice how the f of x graph dips below the g of x graph. It's smaller than the g of x graph. I could have at x equals to 1. I could have at x equals to 1/2, or a quarter, or an eighth. So how many solutions are there? There would be infinitely many solutions, because there's infinitely many numbers in between this negative 1 and positive 3, what it looks like to me. Yeah, well, let's see. I know that the concept of infinity isn't something we've talked about yet, or will talk about in Algebra 2, maybe in your pre-calculus class, and definitely in your calculus class. But if you think about it, you could have 0, you could have 0.01, you could have 0.001, you could have 0.00001. All of those numbers, and I can keep adding zeros in front of that 1 to, produce as many numbers as you want. And so all of those numbers exist in this small little, region of space. So how many answers are there? There's unlimited answers, depending on how many decimal places you'll let me have. Maybe that's a good way to answer it. There's unlimited answers depending on how many decimal places you let me have. And if you're telling me that there's any number that, I can use any number, then there's unlimited numbers I can choose from. All right, let's see. Mark a point on the graph that satisfies f of x is smaller than g of x. Well, I told you. At x equals 0, that's true. F of x is smaller than g of x. Mark a point on the graph where f of x minus g of x is bigger than 0. What are they asking us to do? They said f of x minus g of x is bigger than 0. Maybe another way to look at that is f of x is bigger than g of x. Oh, I get it. What they want us to do is figure out what x values, for what x values is the f of x graph above the g of x graph. All right, Jenna, give me an x value where this is true. Genesis U2, and I keep on screwing up your name, and it's intimidating to me. Keala Kai. That's right, Kai. I'm sorry. I'm really sorry. Kai. Yeah, I know. I know who you are. I know your face. I apologize. It's just, you got to admit, when you look at your name, it's kind of like, whoa, that's pretty crazy. All right. Give me an x value. Here's my question. Give me an x value that will give me, or where I can say that the f of x graph is bigger than the g of x graph, is above it. At x equals 4, I totally agree. At x equals 4, f of x is equal to 0, where g of x is equal to negative 5. F of x is bigger than g of x. Totally agreed. Can anyone think of another one? At negative 3, yes, absolutely. At negative 3, the same case. At negative 4, I don't know what f of x is, but I can definitely tell you that if continuing on the same, if you continue on the same trend, I definitely would say that f of x is going to be bigger than g of x. In fact, yes, absolutely, there are infinitely many solutions. And this one's, it's easier to see that there's infinitely many solutions, because, like at x equals 6, well, f of x is going to be way up here above the computer screen, and g of x is going to be right here. Or f of x, or x equals like 20 or 100 or 1,000 or 1,000,000. I'm sure that if you keep this trend going, this f of x is going to grow faster than the g of x. Are we cool with that? All right, and I'll be honest with you, I think the rest of this is your homework. So here's what I'm going to say we'll do. Let's see. Is at this point, I promised you that I would go and take a look at your homework, and we'll do a couple of these problems. And the reason for me doing this is not because I like doing your homework for you. I spent all this time making your homework, and it's almost like it's almost a pain for me to do your homework for you, because after I make your homework for you, now I'm giving you like the freebies, and it's like all this work I did was for nothing. But at the same time, I feel like this particular homework specifically is a little bit, well, it's not really, it's not, I feel like this homework specifically is a little bit, there's a small thing that I have to make sure I take care of. So I don't mind putting it on recording. All right, let's see. Typing interval notation on a computer is kind of tough. This is going to be a short lesson to teach you how to type interval notation. If we were looking at a number between -2 and 5, non-inclusive, we would write -2, 5, with parentheses on the side because I said non-inclusive. It doesn't include -2 and 5. Typing this into the computer, you would simply type in the, parentheses -2, 5, close parentheses. If you're looking, oops, I screwed that up. Good thing we took a look at this because I screwed this up. There we go. If you're looking for a number between -2 and 5 inclusive, so that means you're putting a bracket around it, you would type in the bracket -2, 5, close bracket. We cool? Now here's the tricky part, and this is kind of what I was telling you guys I ended up doing, is if I needed to type that into the computer, I don't know if you guys would know how to do it. Technically, do you see that little pop-up that kind of appeared? Let me see if I can get it back. Technically, that's what you would type, but what I'm going to have you guys do is just put in parentheses 5, /INFTY, close slash. This is what I had to do in order to type it in order to, make it appear to look like that. But what I want you to type into the computer is this. Are we cool with that? All right. Now I can get a little bit more crazy, and I can say, well, what if I wanted an answer that is x is less than or equal to -2, so it includes -2, or x is bigger than 5, but it doesn't include 5. So I have to include all of -infinity to -2, union 5, infinity, 5 that goes all the way up to infinity. On the computer, what I would type is, all right, so this U-looking symbol in the middle is called a union symbol. And we use it in math, and it means or. It's either this or that. Now, for typing purposes, why don't we just use a capital U in the middle of this thing to identify our union symbol. Okay? So, some general rules. Don't use any spaces when typing up all these intervals. Don't use any capital letters when typing the intervals, except, of course, for the union symbol, which is a capital U. And don't forget the negatives if you need them. So, I think in this homework, let's save this. Let's preview it. This is actually kind of like 4 freebie points, but how would I input all numbers less than 0 inclusive? Okay, I would go like this. -infinity, 0, close parentheses. Oh, wait, no. Inclusive means I would put bracket over there. Because I'm including 0 as well. Does that make sense? Okay. One thing that I want to highlight here is, see that first thing right there, the parentheses? Why did I put a parentheses around the infinity? And the answer is, that parentheses is for when you have a number where it doesn't include that number. And whenever you're talking about infinity, you never have a bracket next to the infinity, because you can never get to infinity. Infinity isn't an actual number that you can land on, so it can't include infinity. Does that kind of make sense? So whenever you have an infinity on one side, it doesn't matter if they're saying inclusive. You have to put a parentheses on the side with infinity, because you can't actually get to the number infinity. All right, let's see. How would I input all numbers that are greater than negative 17 non-inclusive? Can you guys chat this one to me and see if you guys agree? And it looks to me like my screen share crash. I'm going to redo it. But here's my question: how would you do all numbers greater than negative 17 non-inclusive? Try that one on for size. Awesome. But the only thing is you would get that wrong because infinity is something that we abbreviate with INFTY. So you don't type in infinity. You would just, yeah. And you would also use the forward slash, not the backslash. There's this program called LaTeX, and it's a math typesetting program. Most advanced math books are written using this typesetting program. Kai, that would also be wrong. You need a forward slash in front of that INFTY. It's the button in front above the enter key. Hey, KJ, you want to join us? We're doing some math, actually.
Yeah.
All right.
I have to run down and grab something really quick.
Let's do all numbers less than 0 inclusive or greater than 0.5. So, yeah, I'll help you out with this one. Less than 0, that would look like this. From negative slash INFTY to 0 inclusive. So bracket, got it? Or, instead of typing in the word or, I should put in a capital U, because that means union, bracket, 0.5, comma, INFTY. So I have negative infinity to 0, union 0.5 to infinity. Man, my computer connection keeps crashing. Oh, it kicked me out of the thing completely. Did it kick me out of my conference? Yeah. Sorry. Let me join it again. Get this party started. This computer is not letting me get to the thing, back to the thing. So let me type up some of the problems for you. How would I do? I know. It's starting to crash. All right, I don't mind. How would I do all numbers between -2 and 5 inclusive? All right, I want you guys to put in that for me while I try to get this thing up and running. Tell me what that would be. Yeah, don't worry about it. As long as you make sure you have it in your answer key, you'll be all right. So what are all numbers in between -2 and 5 inclusive? Tell me how you would input that into the computer. Well, in observance of time, why don't we just... Perfect! That's exactly it. Bracket, -2, comma 5, close bracket. And you would use the brackets because we're include... Oh, wait a second. Yeah, you're absolutely right. You're absolutely right. When I gave you the problem, I said inclusive, but actually the problem actually asked for non-inclusive. So just to do that, I'm going to change that to a parentheses. But you're right. With the problem I asked you is I said -2 and 5 inclusive, then you would use the brackets. But since I'm saying non-inclusive in the thing, I'm putting parentheses. I guess I typed that up wrong. Let's try submitting this, and hopefully we get a 4 out of 4. All right, good. It looks like it's a 4 out of 4. So the reason why I'm going over this homework with you is just because it's a different way to type up your problem. But like I promised, I will go over some actual homework that's worth points. I mean, and technically that is worth points. So, hey, guess what? I did some homework for you. Let's see. Let's do this one. This one's worth 20 points, so you guys better get it correct. Occasion, what I'm going to do is I'm going to go over some of this stuff with you. You missed kind of our first part of our conversation. So if there's anything you missed after we're done with this class, I'll kind of fill in the gaps that you kind of missed. Cool? All right. Let's see. Did I actually give you... Oh, oops. Looks like for your homework, I did a lot of it for you. My bad. I mean, maybe not my bad, but I realized that in our lecture today, and a little bit from yesterday, I did a lot of your homework for you. All right, we'll do one of these last problems. How's that? Answer the following questions based on the graph. So here's f of x and here's g of x. We already took a look at that graph, and then here's my questions. Using the graph, find when g of x is smaller than f of x. Okay. Looking at that graph, when is g of x below f of x?
Right there?
Okay, Ikasia is saying right here. Yes, I agree with Ikasia. You're saying maybe at like x equals 4?
Mm-hmm.
Or -4?
Yeah.
At x equals -4, I agree with you. You look at where the g of x is way down here, and the f of x is way up there. Kai is saying at -2. Yes, I totally agree with you. Yes, exactly, Jenna. That's only one solution. I'm asking for all of the solutions where x is, what are all the x values that will give me this fact that g of x is going to be below f of x. You said -4. Kai is saying -2, and I agree with him as well. There are infinitely many solutions. Maybe +4. At x equals +4, look, the f of x graph is up here, the g of x graph is down here. So I would almost venture to say that my answer would be all of the numbers in between -infinity to -1. Do you agree? Because at x equals -1, it's where they kind of meet up or equal to. So I can't say one is below the other.
Oh, okay.
So I would say all of the numbers between -infinity and -1, and I wouldn't include it because I'm looking for strictly g of x is less than f of x, not g of x
same.
is less than or equal to.
Mm-hmm.
All right, but I would also include the numbers between 1 and infinity, right?
Mm-hmm.
Or not 1, but 3 and infinity, because this is 2, 4, and so in between here is 3. All right. Oh. Actually, we're done. We're pretty much done. I'm just going to do this one last problem for you, and then we're done. So I want to include the numbers 3 and infinity. So how would I type that up into the problem? And I think that what I would do is I would say, all right, this is what I want to put in. So it's either all numbers, so x is less than -1 or x is greater than 3. This is the way you would write it, you know. This is the way you would do it in interval notation. And then to type it into interval notation, you would type in, let's see if I can do it like this. Pull this on the side. Pull this up and down. Let's see. I would go, parentheses, negative, infty. That's my infinity symbol. -1, close parentheses, capital U, parentheses 3, comma, / infty, infinity. And that's it. That's the best way that I figured out how you guys can write down this answer into the computer. Let's submit quiz, and I know that there's 8 unanswered questions, but I only answered the last one for you. And so let's see what I got as a score. Oh, I got 0. Ooh, that's not good.
Good thing you checked.
You know what? Actually, you know what I want to know is what did I put in and what is the right answer? Oh, I accidentally put a 1 there. I don't know why I put a 1 there. But it's supposed to be a 3. And obviously it was supposed to be a 3. I mean, that was...
It's easy to assume.
Oh, no. Actually, I put the 3 in there, and it should have been a 3. And in the answer, I put in a 1. So my answer was wrong. Sorry. I'm glad I checked that one. Woo! That would have screwed you guys up. Here we go. 3. That's the answer. Wouldn't one infinity say g of x is greater than f of x? Oh, are you saying, wouldn't you say when g of x is greater or infinity? Say, wait, I'm not sure. I don't understand your question, Jenna.
Because the numbers go up from 1.
Oh, are you asking about this interval right here, 1, comma, infinity? Oh, okay. Well, no, you can't do that. Because look, if we look at the graph, maybe I'll make it big. If we look at the graph, still can't see it very well. There we go. If we look at the graph, I can't say +1 to infinity because at +1 or even 2, g of x is actually bigger than f of x.
Mm-hmm.
I have to say above 3. So it's either below -1 or above 3. Yeah, no problem. You can go, Genesis. We're done. I'm just kind of wrapping things up with Jenna, just making sure everyone understands the things that I covered. I actually didn't feel like 7.3 was that bad at all. It's kind of an extension of what we did in 7.2. Jenna, did what I say make sense to you? No, I definitely wouldn't say, if you're asking, no, I definitely wouldn't say 1 to infinity is a solution. No, not at all. I would say my two solutions are between -infinity and -1. and also 3 to infinity. See this point where they cross? That's at 3, not 1. You're right, though. So why was it included in the answer? Oh. You're asking why was that the right answer in the question when I did it? Why was that in the solutions? Oh, okay. The reason being is because I screwed up the answer. That's a pretty easy, explanation. I screwed up the answer, and I just fixed it now. When we originally did it, when we did it together, you and I were sitting down. I put in a 3, and then it marked it as wrong, and I was like, wait a second, why is it wrong? And then I looked at the answer key, and I realized the answer key was wrong. It's because I included 1 to infinity, and it shouldn't be that. By the way, Jenna, just to kind of give you a heads up, don't type out the word infinity. Type in /INFTY. There's a really popular way of writing math. It's called LaTeX. It's spelled like latex.
Oh, I was like that.
Yeah, I know. When I tell people, oh, hey, use this program called LaTeX or LaTeX, they type it in and they find all kinds of like creepy websites.
Mm-hmm.
And no, it's LaTeX. It's pronounced LaTeX. It's spelled latex. But let's see, LaTeX equation editor. It's a really good program. What I used to do when I was in college is I would sit in my math class and actually just bring a computer and not bring a pencil and paper. And my math teacher would write up all of these math equations, and I could literally type my math out faster than he could write it. So like watch, if I type in INFTY, it gives me an infinity symbol. You see that?
Oh, I see that. You can like copy and paste it.
Well, like here, I'll show you a little bit of LaTeX. We're done, by the way. You guys can go. But like, if I wanted to do like some math symbols, like fraction 1/2, fraction 1/2, or how's about negative b plus or minus the square root of b squared minus 4ac all over 2a. Look, it's the quadratic equation.
That's really cool, but like, don't you have to know the abbreviations that they?
Yep. It's almost like a programming language.
Mm.
But like it's a programming language that makes sense. Like
Yeah, it's not good.
fraction is just frac, and then you put 2 curly brackets, and the 2 curly brackets, the first thing is your numerator, and the second thing is your denominator. So if I put a 1 and a 2, it's going to give me a 1/2. There's a lot to learn with LaTeX, but
Once you learn it, it's like
it's like a program that's been used since like the 70s, and I learned it back in 2000, and I've been using it ever since. Anyway, yeah. All right. Have fun with your PSATs. You guys are done. I'm done with the class today.